Topic 2. Logical equivalences. Two statement forms are called logically equivalent if and only if they have identical truth values for each possible substitution for their statement variables.
So, number 1. Show that each of these conditional statements is a tautology by using truth table. So, conjunction P implies Q, then Q implies R, and negation P implies R. So, mo niya itong unahon. I'll insert a table here. So, mo niya itong unahon is kaning na I bracket. So, kay conjunction man ta. So, first is ang conjunction P implies Q, then Q implies R. So, let's go to the truth table. So, P is truth, true, 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 false, 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 and false. And then the Q is true, true, false, false, true, true, false, false. Then sa R is true, false, true, false, true, false, and true, false. And then sa conjunction P implies Q is true, true, false, false, and then true, 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 and true. So sa Q implies R is true, false, true, 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 false, and true, true. So sa conjunction P implies Q, then Q implies R is true, false, 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 true, false, true, true. And then sa P implies R is true, true, false, false, then true, 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 true. And then sa conjunction P implies Q, then Q implies R, and negation P implies R is true, 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 and true. So, number 2. Conjunction of P, this conjunction Q, P implies R, and Q implies R in the integration of R. So, P is true, 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 false, 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 false. I'll insert a photo here. So, and the Q is true, true, false, false, true, true, false, false. And then sa R is true, false, true, false, true, false, and true, false. And then sa conjunction of P, this conjunction Q is true, 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 false, false, false. And then sa conjunction of P, this conjunction Q, P implies R, and Q implies R is false, 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 false. So sa conjunction of P, this conjunction Q, P implies R, and Q implies R, and the integration of R is true, 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 true. So, number 2. Use De Morgan's law to find the negation of the following statements. Letter A. John is rich and happy. So, John is rich and happy will P. In Morgan's law, P conjunction Q will be negated. P conjunction Q is equivalent to negated P conjunction Q. So, let P be John is rich and Q be happy. Then, John is rich and happy can be represented by P conjunction Q. By the first of De Morgan's law, P conjunction Q is equivalent to P conjunction Q negated P conjunction Q. Consequently, we can express the negation of our original statement as John is not rich or he's not happy. So, letter B. Carlos will ride a bicycle or run tomorrow. In Morgan's law, R disjunction S will be negated. R disjunction S is equivalent to negated R conjunction negated S. So, let R be Carlos will ride a bicycle and S be run tomorrow. Then, Carlos will ride a bicycle or run tomorrow can be represented by R disjunction S. By the second of De Morgan's law, R disjunction S is equivalent to negated R disjunction S. Consequently, we can express the negation of our original statement as Carlos will not ride a bicycle and he will not run tomorrow. So let's go to letter C. Show that the problem is logically equivalent using A is the truth table and B equivalence is loss. So let's go to the truth table. So by conditional P and Q and P by conditional Q, P is true, true, false, false. Q is true, false, true, false.